My name is Saritha Kumari, working as Assistant Professor EEE Department in Institute of Aeronautical Engineering College. Today my lecture is about uh, how to calculate equivalent resistance and equivalent capacitance. So problems I'm going to explain. Consider first problem is based on equivalent resistance. Equivalent resistance R equivalent. So the problem is given, calculate the R equivalent of the given circuit. So, and the circuit given like this. So here the problem, the supply is shown, the supply battery which is having value 5 volts, and with the resistors R1, okay, values are given R1, 4, R2, 4, R3, R4, R5, R6, R7, whose values also mentioned. So how to calculate the R equivalent for this problem? So, excuse me, here they have not shown where this R equivalent is requires to be calculated. So if it is not mentioned, we need to know that R equivalent nothing but across the supply. Across the supply. That means here R equivalent is supposed to be calculated. Okay. So now the procedure to calculate this is, we have to start from the opposite side of the point where R equivalent is shown. We have to reduce the circuit from the other end of the point where this R equivalent is shown. So here R equivalent is shown. Okay, according to the problem, R equivalent means here at this place across the supply. So I start reducing the circuit from the other side, opposite side. Okay, so each time I find the equivalent value of two elements. Okay, each time I reduce two elements as one element. Okay, by knowing series connection of two resistors, what is its equivalent value, what is a parallel connection of two resistors. Okay, like that. So first I start with the other side, means this R6 and R7 already you can see on the slide. So this R6 and R7, its equivalent is given by, see that you have to know whether they are in series or parallel. So if two elements are in the same path, if the two elements are in the same path, same line, yes or no, same line, they are in the same line. Okay, that means same current flowing through both of them. So that means they are in series. That is the meaning of series connection. Same current flows through the elements. Okay, but voltage divides. So if the two elements are in the same line, then that means they are in series. Okay, and if they are in different paths, different lines, means current is dividing, means they are in parallel. Okay, so here first step, equivalent of R6 and R7, they are in the same line, so they are in series. So we know that when two resistors are in series, what is its equivalent? Sum of the two elements. So simply 2 plus 2, R6 plus R7. So that's why these two elements equivalent is given by 4. So next circuit, my circuit is, okay, those two are replaced with 4. Okay, then next element we have R5. So the equivalent of this equivalent of this R5 and 4. So you have to know whether they are in series or parallel. So if you see, they are in the different, they are in the different paths. Okay, different lines, means current dividing, means they are in parallel. So next step, R5 and this 4, okay, are in parallel. So when two resistors are in parallel, we know what is its equivalent. R1, R2 by, okay, product of the two elements by sum of the two elements. So 4 into 4 by 4 plus 4. So that is nothing but 2 ohms. Okay, so next circuit. So replace these two with the a resistor value 2 ohms. So that's why that is the next step. So now what is the next we can do? You can see from the circuit this 2 and this R4 are in the same, they are in the same path. So same current flows, means they are in series. So R4 and 2 ohm. So next we can replace those two with a value, okay, 10 plus 2, okay, they are in series. That's why 10 plus 2, okay, so whose value is given by, equivalent value is given by 12 ohms. 12 ohms. Okay, so next circuit, okay, show these two with a single value, a single resistor whose value 12 ohms. Okay, so now what is the next thing? So next step is replace the two elements. Next two elements, this R2 and R3. This R2 and R3, they are in the series. They are in a series connection. So we know that series connection means the equivalent of those two is given by simply the sum. So 4 plus 8. So those two are replaced with a single resistor value 12 ohms. Okay. Next, what is the next step? Okay, next step is the equivalent of these 12 ohms and this 12 ohms. Equivalent value of this 12 ohms and this 12 ohms. So we know that equivalent of two resistors in parallel means multiplication by sum. So 12 into 12 by 12 plus 12. So 144 by 24, which gives a value of, you can see here, which gives the value of 6. Okay, 6 ohm. Now, so replace those two resistors with a resistor whose value 6 ohm. So this 6 and, okay, now this 6 ohm. Now what is the next step? This 6 ohm and the resistor R1. So if you see from the connection, you can see they are in the same path. Means same current flows, right? Same current flows. This 6 ohm and 4 ohm, okay, R1, they are in the same path, means they are same path means they are in series, same current, that means so they are in series. So the equivalent of those two is given by sum 4 and 6, 4 plus 6, whose value is 10, okay, 10 ohm. So finally across the supply, okay, we have the resistance whose value is given by 10 ohms. So that is nothing but R equivalent of this given circuit. So finally the answer R equivalent for this given circuit is given by how much? 10 volts. R equivalent for this given circuit is given by 10 volts. So that is how R equivalent is calculated here. Okay. So that is our answer. R equivalent is given by 10 ohms. Next one more problem. So calculating the equivalent resistance only. Okay, calculate the equivalent resistance for the given circuit shown in figure below with the step-by-step explanation. So they asked for step-by-step explanation, means we have to show each time the reduction of two elements, simplify the two elements into a single value, okay, by knowing whether they are in series or parallel. Okay, each time you have to draw the circuit, okay, then finally at last the equivalent resistance value. So here the circuit is given like this, and they clearly also mentioned, they have also clearly shown where is this R equivalent. So they have shown the equivalent resistance here, the terminals across the terminals AB, small terminals AB. So here, whose answer? This is a circuit given. Okay, so R equivalent. So here we need to find across this terminals AB with an arrow. It is shown. So these are the elements, various elements, values. Now find the R equivalent here. Okay. Um, so R equivalent here means we know all how to start. We have to start to reduce the circuit from the other end. Okay, from the place where this R equivalent is shown. So at this point, R equivalent is shown. So I start reducing the circuit from this side. Each time two elements. Okay, replace it with a single element. Okay. So here finally this is the answer for this circuit that is also shown. So first step, this is a circuit, right? So first step is what? You can see these two and these two are in the two elements. Okay, they are in the, these two are the two elements and the equivalent of these two. So the equivalent of these two means you need to know whether they are in series or parallel. So if you see they are in the same path, they are in the same path. Okay, means same current flows. So they are in series. So first step is the circuit. The circuit is drawn and this value is given by 2 plus 2, whose value is 4. Okay, they are in series. That's why simply the sum. Next step. What is the next step? This 4 and this 4. Okay, so from the connection, we can understand that they are in the different paths. Means different currents. Means they are in parallel. So next step. Next step is given by this 4 and this 4 in parallel. 4 into 4 by 4 plus 4. 16 by 8, 2. Okay. So these two are replaced with a resistance value 2. Next step. What is the next step? Two elements, right, at a time. These two and these two. These 2 ohms and these 2 ohms. They are in the same path, right? Means same current flow. So they are in series. So 2 plus 2, 4. Next step. So what is the next step? Before going to look at this element, before that we have to understand the before branch also. So if you see here, before one, this 2 ohm and this 2 ohm, they are in parallel. So simplify those. So this 2 and this 2 ohm, they are in a different path. They are in a different path, not in the same path, right? So they are in, that means they are in parallel. So the parallel combination of two resistors, 2 and 2. So 2 into 2 by 2 plus 2. 4 by 4, 1. So 4. This is the next element. So after this what? Okay, next how can you simplify? Okay, next is this 3 ohm and this 1 ohm. This 3 ohm and this 1 ohm, they are in series. 3 and 1. So means they are in the same path, right? So series connection. So 4 and this is also 4. Okay. Now finally only two branches with the values 4 ohm and 4 ohm. So the combination, the equivalent of those two, they are in different paths, so that means different currents. So parallel combination of two, product by sum, so 16 by 8 2. So finally, what is answer? What is answer? The equivalent resistance for the circuit, given circuit is given by, given circuit AB, terminals AB, it is given by 2 ohm. Okay, for this circuit, the R equivalent is given by 2 ohm. Answer, that is a value also mentioned previous slide. So answer is obtained. Okay, next problem. So next problem is based on equivalent capacitance. Equivalent capacitance. So the series capacitors, when capacitors are in series, okay, how to calculate the equivalent capacitance when the capacitors are in parallel, okay, how to calculate the equivalent capacitance. So we know that already, okay, when two capacitors are in series, when two capacitors are in series, C equivalent is given by, what is the C equivalent when two capacitors are in series? Product by sum, okay, C1 C2 by C1 plus C2. When they are in parallel, when they are in parallel, that is given by sum. Okay, this is opposite to resistors connection, series parallel connection of resistors. Okay, whereas inductors series parallel connection equivalent is same as the resistors series parallel connection. When inductors two, let us say two inductors L1 L2 are in series, its equivalent is given by then sum of the two inductors L1 plus L2. When two inductors L1 L2 are in parallel, its equivalent is given by the product over sum L1 L2 by L1 plus L2. So now we are we have the problem now based on the C equivalent, okay, equivalent capacitance. Look at the problem. If three capacitors are 10 farad, 12 farad and 5 farad capacitance, calculate the equivalent capacitance for series and parallel connection. Okay, the first thing is they mentioned values of the resistors values of capacitors, three values, okay, 10, 12, 5. Okay, now they're telling that they're in series and parallel connection. So first for series connection, okay, so series connection, three capacitors series, values like this. So first these two are in series. So when two capacitors in series, product by sum, right? So this is a value. Then the equivalent of this two, 10 and 12 in parallel with 5. So what is the equivalent value of this? 10 into 12 means 120 by 22. Okay. So whose value 60 by 11. So 5.4 farad. Okay. Let us say. So now, the next step, this 5.4 in series with 5. So these two are in series now. So 5.4 into 5 by 5.4 plus 5. Okay. So whose value approximately 5.4 into 5 means 27 by 9 means almost 3, but exactly the answer is given 2.6. So if we calculate exactly, we will get the answer 2.6. That is for the series connection, right? That is for the series connection. Next, parallel. So draw the three capacitors in parallel. Okay, 10, 12, 5. So calculate the C equivalent here. Okay. So now we know that when two capacitors are in when capacitors are in parallel, what is its equivalent? Okay, so first consider two capacitors at a time. So two capacitors at a time means, so if you consider, or at a for parallel connection, we know that the equivalent value is given by simply the sum of the all capacitances. Okay, that is what the basic relation. So when number of capacitors are in parallel, so the equivalent value is given by 10 plus 12 plus 5. So whose value is 27. So three capacitors, for this given three capacitors, 10 farad, 12 farad, 5 farad, parallel connection of these three is given by, equivalent capacitance is given by simply the sum of the three capacitors, 10, 12 and 5. So 20, totally total the value is given by finally 27 farads. So that is the answer. So this is how the equivalent capacitance is calculated. Okay, for the problem given based on the series connection of capacitors or parallel connection of the given capacitors. Okay, so previous problem I have explained about the equivalent resistance, okay, in the given circuit, for the given circuit. Okay, then also similarly equivalent inductance also. Okay, similarly the same manner we can calculate the equivalent inductance also. Okay, that's all for now for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.